All right, let's look at a problem that deals with circular motion and NLUG, Newton's law of universal gravity. It says a satellite is orbiting around a 6.1 times 10 to the 23rd kilogram planet with a radius of 7.8 times 10 to the 6 meters from the center of the planet. What is the tangential velocity of the satellite? My first thought is let's take a look at velocity. V equals 2 pi r over t. The problem is, if you look at the problem, there's no time, at which point many of us might give up. But let's take a look at what this problem actually is involving. It's involving a planet with a satellite that's going around it. And we happen to know the radius, or the distance that the planet is from the satellite, or the satellite is from the planet. And we know that it's going in a circle. And hopefully we think, wow, that means there's a centripetal force. And then the second question should be, well, what is the centripetal force? What is keeping the object in a circle? And in this case, we're dealing with gravity, because two objects have a gravitational attraction to one another. So I'm going to set centripetal force equal to gravity. mv squared over r equals gmm over r squared. And look at that equation, I realize, well, there is an m on both sides. The question is, well, which m is it that's the same, and which one do I cancel out? And you'll notice that the m that is on the left side, on the centripetal force side, that's the object that's actually going in a circle. And so the mass of the satellite is the one that we don't need. That's the one that gets canceled on both sides. It's also important to note that there is a radius, or a distance, on both sides. And so you're going to cancel 1r on the left and the squared on the right. After that, I'm going to plug my numbers in. It's going to be the square root of that gravitational constant, which is 6.67 times 10 to the negative 11th meters squared per kilogram squared. I'm going to multiply that by the mass of the planet and divide it by the radius, or the distance between them. Take the square root, and I arrive at my velocity. 2,283.9 meters per second. That is the tangential velocity of the satellite as it travels in a circular orbit around the planet.